Hello students, in this video we are going to solve the problems of exercise 13.2 of NCERT textbook of mathematics class 11 from question number 9 to question number 11, because we have already solved question number 1 to question number 8 in the last video. In the previous video I have shown you, and link of that video is given in the description box. Okay, so please watch that video before you watch this. Okay, so now let us start. Now let us solve question number 9. Here we need to find the derivative of these functions given here. Okay, so the first one is y is equal, you can write instead of y f of x also, y is equal to twice x minus 3 by 4, and therefore y dash means derivative of this function, or you can write dy by dx. Same mean both of them means the same, so that's why you can write only one of these two. Okay, so derivative of twice x minus 3 by 4. So remember one thing, that suppose you need to find a derivative of sum of or difference of two functions, f of x plus or minus g of x, then you can find it separately. Derivative of fx, derivative of gx. Okay, like this. Okay, remember that. So here what we can do, we can find derivative of twice x minus derivative of 3 by 4. So here you see this is constant 2 and there is x. Okay, so 2 will be taken outside, and derivative of x, if you apply this standard derivative ddx of x to the power n, which is equal to n into x to the power n minus 1. So here we have x to the power 1, so or ddx of x, then it will be 1 into x to the power 1 minus 1, that's going to be 1 into x to the power 0, which is going to be 1. Okay, so here you can write only 2 minus, and derivative of constant is 0, so here is the answer 2. Okay, that's very simple. So now next one is number 2. So on the right hand side, let me show you the number 2. So 5x cube plus thrice x minus 1 and x minus 1. Okay, so here we are going to apply the product rule, u into v. If u and v both are functions of x, if you consider this one as u and this one as v, then how to find the derivative? First function, that is u, derivative of the second function, this dash represent derivative, plus second function, derivative of the first function. Okay, so hope you have understood this. So let us apply that. So y dash will be equal to 5x cube, that is thrice x minus 1, this is the first function, derivative of the second function, then plus second function, that is x minus 1, derivative of the first function again, that is 5x cube plus thrice x minus 1. Okay, so let me write it properly, thrice x. Okay, now so here we are going to apply standard derivative. So 5x cube plus thrice x minus 1, derivative of x is 1 and derivative of 1 is 0 in this case, so that's why we will get this only, then plus x minus 1 into, so now derivative of 5x cube. So if you, here you see, so derivative of 5x cube, what will be its derivative? So it will be 5 derivative of x cube. If you apply the standard derivative, the ddx of x to the power n, then you will get 3 into x to the power 3 minus 1, that is x square. Okay, so here 5 3 is 15, you will get 15x square. So let us write here 15x square. Okay, derivative of 5x cube, 15x square. Similarly here derivative of thrice x, so derivative of x is 1, so we will get 3 into 1, that is 3, and derivative of 1 will be 0, derivative of constant is 0, so we can keep it like this. Okay, so hope you have understood this. So now just simplify 5x cube plus thrice x minus 1, and if you multiply these two, and what will happen? So you will get 15x cube plus thrice x minus 15x square minus 3. Okay, you will get this one. So now here you see plus 15x cube 5x cube, that's going to be 20x cube. Then we have thrice x plus thrice x, that's going to be 6x. And before that let us write the square term 15x square. Okay, then let us write 6x, then minus 1 minus 3 is minus 4. Okay, so this is our answer. That's how we can solve the second. So now let me show the third one. Number 3, y is equal to x to the power minus 3 5 plus thrice x. So here also we are going to either we have to multiply these two, or you can consider u and v. So let us multiply here first. 5x to the power minus 3, and if you multiply thrice x into x to the power minus 3, it's going to be x thrice x to the power minus 2, isn't it? So x to the power minus 3 into x to the power plus 1, that's going to be product of this is going to be minus 3 plus 1, isn't it? So it's very simple. Okay, so I hope you have got this. So therefore y this will be derivative of 5x to the power minus 3 plus derivative of thrice x to the power minus 2. Okay, so if you apply the standard derivative ddx of x to the power n, okay, then derivative of x to the power n is n into x to the power n minus 1. If you apply that, you will get 5 into minus 3 x to the power minus 3 minus 1, then here 3 into minus 2 x to the power minus 2 minus 1. Okay, minus 15 x to the power minus 4 and minus 6 x to the power minus 3. So that is our answer. Okay, so now let me show you the next one, that is number 4. Here it is y is equal to x to the power 5 3 minus 6x to the power minus 9. Okay, so here you can similarly multiply, or you can apply u and to v also. Instead of that, it will be better if you multiply in this case. Okay, 6x to the power minus 9 plus 5, that's going to be minus 4. Yes, now find the derivative. So derivative of thrice x to the power 5 minus 6x to the power minus 4. Okay, if you find the derivative, then you will get 3 into 5 x to the power 5 minus 1 and minus 6 into minus 4 into x to the power minus 4 minus 1. Yes, so that's going to be 15 x to the power 4 and minus minus plus 6 for the 24 and x to the power minus 5. So that is your answer. That's how you can solve. Very simple. Okay, now let me show the 5th and 6th. Okay, so for that let me clear this. Let me mention one more important thing here. Those answers I have obtained here, so those are maybe not in the form as given in the book. Okay, so in the book answers are given, isn't it? So those are maybe not they are not similar to my answers. Maybe those are more simplified form, but nothing to worry about that. These answers are also correct. Okay, so this is the number 5. Okay, how to solve this? X to the power minus 4 3 into 4 x to the power minus 5. So this is equal to suppose y. So now if you multiply this here and here, then you will get 3x to the power minus 4, then minus 4x to the power minus 4 minus 5 minus 9, isn't it? Now let's find the derivative of this 3x to the power minus 4 and minus 4x to the power minus 9. That's gonna be 3 into minus 4 x to the power minus 4 minus 1, then minus 4 into minus 9 x to the power minus 9 minus 1. So it's going to be minus 12 x to the power minus 5, then it's going to be minus minus plus 4 9 is 36 x to the power minus 10. So this is our answer. Now let us solve this one. 6. So here y is equal to number 6, y is equal to 2 by x plus 1 minus x square thrice x minus 1. So derivative of this will be derivative of 2 by x plus 1. We can find the derivative separately, isn't it? So x square thrice x minus 1. Here you see, you can consider, here you see this 2 is the constant, and derivative of 1 by x plus 1, this can be considered as this can be written as x plus 1 whole to the power minus 1. Now derivative of, so let me write this one in the next way. Now here you see, let me explain this one. Here in this case, first you need to consider this one as x, whole thing as x to the power minus 1. That means here you see this is function of function, f of not x, f of g of x. That means this type of function. So in this case you have to differentiate this, considering this one as x, f dash g of x, then you have to multiply the derivative of g of x. Okay, so similarly we will do here the same thing. Okay, so then if you do so, then what will happen? Here you see derivative of x to the power minus 1, that's going to be minus 1 into x to the power minus 1 minus 1. So x to the power minus 1 minus 1 minus 2, that's going to be minus 1 by x square. You can consider like this. So here also you will get minus 1 by x plus 1 whole square. Then as it is not x, it is x plus 1, then again you need to find the derivative of this x plus 1. Okay, x plus 1, and derivative of x plus 1 is nothing but 1. Derivative of x is 1, derivative of 1 is 0. So 1 plus 0 is 1. So that's why you can write here 1 only. Okay, and in this case we are going to apply u by v rule. Okay, quotient rule. Okay, so according to that rule, derivative of u by v was denominator derivative of the numerator minus numerator derivative of the denominator by denominator square. We are going to apply this. Okay, v is the denominator here, u is the numerator, isn't it? So in this case what we're going to do, we are going to do here, we will get thrice x minus 1 whole square, and this is denominator thrice x minus 1, and derivative of the numerator ddx of x square minus numerator, that is x square, derivative of denominator, that is thrice x minus 1. Okay, so here you see derivative of x square is twice x simply, isn't it? So if you, so let me write here thrice x minus 1 into twice x, then x square, and derivative of thrice x minus 1, derivative of thrice x will be 3, derivative of thrice x will be 3. So here it is 3, and derivative of 1 will be 0. So that's why 3 minus 0 is 3, isn't it? You can write here 3. So here thrice x minus 1 whole square. Okay, so now let me clean this here. Now what we can do, let me scroll up the page. Okay, so here we will get, from this we will get minus 2 by x plus 1 whole square minus, so here if you simplify the numerator, then what will happen, you will get 6 square minus 6x square minus twice x, then here thrice x square by thrice x plus 1, sorry, minus 1 whole square. okay, and that's going to be equal to minus 2 by x plus 1 whole square minus 6x square minus thrice x square minus twice x by thrice x minus 1 whole square. So that is our answer. So hope you have understood this. So now let's move on to the next question, question number 10. Okay, so here is the question number 10. Find the derivative of cos x from first principle. So using first principle we need to find the derivative of cos x. Okay, so now let me show you how to solve this. Okay, let us consider f of x is equal to cos x. Okay, so what is the first principle? According to the first principle, f dash x, that means derivative of fx, is given by limit h tends to 0 f of x plus h minus f of x by h. Okay, so we're going to apply this here. So here you see f of x is cos x, then what will be f of x plus h? So it must be definitely cos x plus h. And f of x is cos x, isn't it, by h. Okay, so here what we're going to do, here we are going to apply this trigonometric identity cos c minus cos d, which is equal to 2 sine c plus d by 2 sine d minus c by 2. Okay, we are going to apply this. Yes, so if you apply this, then what we will get, 2 sine x plus h plus x by 2, then we will get x minus x minus h by 2. Okay, so we have applied this identity, yes, by h. Okay, so then limit h tends to 0, what we will get, 2 sine, so here we will get twice x plus h by 2, and here xx gone, we will get sine minus h by 2. Okay, and then what we can do, so here you see sine minus sine minus theta is minus sine theta. Okay, that's why we will get limit h tends to 0 minus 2, here sine, it will be x plus h by 2, and here sine h by 2 by h. Okay, so now what you can do, now you see limit, suppose x tends to 0 and f of x into g of x. In that case what we can write, limit f of x tends to 0 into limit x tends to 0 g of x. We can write like this, isn't it? So similarly, same thing we are going to do here. So what we gonna have here, let me scroll up the page. Okay, so here we will get limit h tends to 0, as 2 minus 2 is constant, it can be written here outside, sine x plus h by 2 into limit h tends to 0 sine h by 2 by h. Okay, we can write like this. Now you see these two, we can write this 2 here as h by 2, isn't it? Okay, when you will simplify, then again you will get the previous step. So here you see, as h tends to 0, we can say h by 2 also tends to 0. Yes, when h will be 0, when h will be equal to 0, h by 2 will be also equal to 0. Okay, so that's why instead of h tends to 0, here we can write h by 2 tends to 0. Okay, so hope you have understood this. Now in this case we can directly put h is equal to 0, and putting this we will get minus sine x plus 0, x plus 0 or 0 by 2, that will be 0 again. And here you see this is standard integral, standard limit. What is that? Limit x tends to x, sine x by x is always equal to 1. Okay, so here you can consider this one as x, h by 2 as x, then you will get this. Okay, so that's why this parts become 0, not 0, equal to 1. Okay, so these parts become equal to 1, so you can write here into 1. So that's going to be minus sine x. So this is the derivative of cos x, that is minus sine x. So that's how we can solve it from first principle. Now let us solve question number 11. Find the derivative of the following functions. So here the first one is sine x cos x. So let us consider this one as y. So derivative of this function, here you see, let us consider this one as u, this one as v. Okay, so we know derivative of u into v, where u and v are the functions of x, then u derivative of v plus v derivative of u, that means first function derivative of second function derivative of first function. So we're going to apply that. Okay, so here sine x derivative of cos x plus cos x derivative of sine x. So we know derivative of cos x is minus sine x, so sine x minus sine x, cos x, derivative of sine x is cos x, so cos x into cos x. So here we're going to have minus sine square x, and here it is cos square x. So this is our answer. So answer may be like this in the book: cos square x minus sine square x, which is equal to cos twice x. Okay, now number 2, here we have sec x. Okay, so it's very simple. Derivative of sec x is sec x tan x, sec x tan x. Derivative of sec x is sec x tan x. Okay, now next one is number 3. Number 3, here y is equal to 5 sec x plus 4 cos x. Okay, so derivative of this function will be derivative of sec x plus 4 derivative of cos x, and derivative of sec x is sec x tan x, and derivative of cos x is minus sin x, so here we will get minus 4 sin x. So this is our answer. Okay, so hope you have understood this. Now let's solve number 4. Here number 4, derivative of cosec x. So y equal to cosec x, suppose. So derivative of cosec x is just minus cot x cosec x. This is equal to minus cosec x cot x. Okay, it's very simple. So similarly we can solve the remaining also. Let me show it. Number 5, we have derivative of, we need to find the derivative of 3 cot x plus 5 cosec x. Okay, so let us find the derivative. So it's gonna be 3 derivative of cot x plus 5 derivative of cosec x. So we know derivative of cot x is minus cosec square x. Okay, and derivative of cosec x is minus cot x cosec x, or cosec x cot x, same thing. Okay, so that's how you can solve. So you can take cosec x common also. Okay, so let us keep it like this. Okay, so now let me clean this. Okay, now we are going to solve question number 6 of question number 10. 6 of question number 10, sorry, not 10, 11. So here y 5 sin x minus 6 cosec x plus 7. So now let us find the derivative. So here 5 sin x minus 6 derivative of cosec x, and derivative of constant is 0, and derivative of sin x is cosec x, sorry, cos x, and derivative of cosec x is minus, so here it will be plus, minus, minus, plus cosec x cot x. So this is our answer. Similarly we can solve 7 as well. So number 7 of question number 11, y is equal to 10x minus 7 sec x. So derivative of this, derivative of 10x minus 7 derivative of sec x. So derivative of 10x is sec square x, and derivative of sec x is sec x 10x. So here 7. Okay, this is our answer. That's how we can solve. So this exercise is complete. Now in the next video I'm going to show you how to solve the problems of miscellaneous exercise of chapter 13. Okay, so hope you have understood, and if you think that this video is helpful for you, please subscribe my channel if you are new, and please do share my videos with your friends and like my videos. Okay, thank you.